Hi girls, so I just wanted to show you a few more examples of some relationship between roots and coefficients in polynomials questions. So I'm just going to start with a cubic. So we'll go 3x to the 4. I'm literally making this up on the top of my head right now. Plus 2x cubed plus 7x squared minus 1x, or minus x, minus 5. And let's say, first of all, I want to find alpha squared plus beta squared plus gamma squared plus delta squared, where alpha, beta, gamma, and delta are the four roots of the polynomial. So whenever you see something like this, I mean, hopefully eventually you'll just memorize exactly what to do because you'll do it so often. But whenever you see something like that, I'm hoping that you're always thinking, well, what if I have the sum, because I know something about the sum of the roots, and I square it. Because I know if I get that and I do FOIL, so it's going to be everything times everything else, so it's going to be alpha times itself, alpha times beta, alpha times gamma, alpha times delta, with some doubling. So I'm going to get alpha squared, beta squared, gamma squared, delta squared, which is a good first start. Okay, so I'm just going to write down the result for what it actually is. So it's alpha squared plus, sorry, something went weird there, beta squared plus gamma squared, sorry, delta squared, gamma squared, wrong order, but anyway, plus 2 lots of the sums of the roots in pairs. So what have I left off? Beta gamma plus beta delta plus gamma delta. Okay, and the reason is just like I was explaining before with FOIL, if I just imagine expanding the first bracket, the alpha, so it would be alpha times alpha, alpha times beta, alpha times gamma, and alpha times delta. So there's my one lot of alpha beta, one lot of alpha gamma, one lot of alpha delta. Then in that same bracket, if I expand the beta, it will be beta alpha, beta squared, beta gamma, beta delta. So there'll be my second lot of alpha beta, my first lot of beta gamma, my first lot of beta delta, and so on. And eventually, hopefully you'll see, but you should expand it in full if you don't see. Hopefully you see that you will eventually get exactly what I've got there. And now this equals, so the left-hand side, I know, so the sum of the roots is always minus b on a. So it's minus b, which is 2 on 3, all squared, equals what I want, plus 2 lots of, so it always goes minus b on a, c on a, and this is the second thing, so 2 lots of c on a. And then, I'm not going to do it just because it's not going to fit in this slide, a bit of algebra by subtracting this across will give me the required result. And you might notice that that's going to be a negative number, and it's worth thinking about why. So next up, we're going to find 1 on alpha beta gamma plus 1 on alpha beta delta plus 1 on alpha, sorry, no, I've already used up all my alphas. Have I? No, I haven't. Alpha gamma delta plus 1 on beta gamma delta. That's what I'm looking for. Okay. So first thing I do is I get a common denominator, which will be quite nice, of alpha beta gamma delta. And then hopefully you can see the first one, what's missing is delta. The second one, what's missing is gamma. The third one, what's missing is beta. And the fourth one, what's missing is alpha. So this is the sum of the roots divided by the product of the roots. So the sum of the roots we've already done, that was 2/3, divided by the product of the roots. So it goes minus b on a, c on a, minus d on a, e on a. So it's minus 5 on 3. So what's that going to be? Keep flip change. The minus, see you later 3's, so it will be minus 2/5. Next one I'll do is I want to find alpha plus 1 times beta plus 1 times gamma plus 1 times delta plus 1. Oops, didn't need the last. So, rather than finding alpha, beta, gamma, delta, which would be painful, I expand. So I get alpha. Oh, this is actually going to be worse than I thought it was going to be. Alpha beta plus beta plus 1 times gamma delta plus... no, actually, no, it's not that bad. Sorry, I'm going to start again. So you can kind of think about this as how many ones are you picking out of the brackets. So when you expand the brackets, you're either picking that one, the letter, or the 1. Okay, so in the first case, if you, from all these things, you pick no 1s, then the factor that you get is alpha, beta, gamma, delta. Plus, so all the ways to choose 1, 1. So if I choose 1, 1, so let's say I choose this one, then what's left over is beta, gamma, delta. And then I've done that one, so that one's done. So then what if I pick this one? Well, it'll be plus alpha, gamma, delta. And you can probably see what's happening at this point. It's the sum of the roots in 3s, isn't it? Beta, alpha, gamma, and beta, alpha, delta. And then if you pick 2 1s, so it's going to be, hopefully you can see, the sum of the roots in pairs. And then if you pick 3 1s, it's going to be the sum of the roots. And then if you pick 4 1s, it's going to be 1. And we'll probably do this question again in class tomorrow and check that that expansion works. But hopefully you're moderately convinced at least of what to do there. And then so it's a matter of picking out the right things. So let's start at the end. So it's 1 plus minus b on a plus, I have to go back, c on a minus d on a plus e on a. And then you get, what's that, 1 plus 5/3, I think. So you get 8/3. Okay, I think I'll stop there. So this is what we're doing tomorrow, questions of this type. There'll also be a lot more word problems and things, just like we've had in 2 now. Alright, I'll see you tomorrow.